Hello and welcome to another video in the series discussing the UC 2014 ESRI and OSIsoft integration demo. In this video we'll focus on the server-side code. In previous videos we gave an overview of the demo, and also we discussed the architecture. If you haven't seen those videos, I would like to invite you to have a look. It might give you a better understanding on what we're discussing here. A little disclaimer. We are OSIsoft and ESRI. We are really committed to releasing actual products that will help you integrate between both systems. Right now we're not there yet. We are providing this demo software and the source code to help you in your researching efforts. So please use this as a reference material only, and please don't use this in a production environment. Some important resources. If you want to have a look at the live demo, you can do so by going to vcamp.us/UC demo site. This will take you to our web client, and you can interact with it and see what the functionality is. You can also have a look at the source code. That's also the source code we're discussing in this video. You can go to vcamp.us/UC demo download. Also, we would really like to invite you to engage in discussion at our users community. If you follow the link listed under discussion, that will take you to the appropriate forum on the users community, and we would really like to invite you to give us your feedback and help us create a better product. Also, in this demo we are using ArcGIS Online. If you're not familiar with ArcGIS Online, this is ESRI's cloud offering that will allow you to use maps, configure different layers in a map. They offer a 30-day trial subscription. So if you are not subscribed yet, I would really invite you to go there and have a look. So in this video we're discussing the server-side code of the demo, and that's really all about asset synchronization, or propagating assets coming from PyAF to a GeoEvent server or GeoEvent processor. This application is written in .NET 4.0 using C#, and the project is really a hybrid console application and Windows servers. So this will allow you to debug it, use it on your development workstation, but you can also install it as a service on your development server. You can do so by using the install or uninstall flags to install it or uninstall it as a service, or you can run it with the console parameter and run it as a console, and you will get the debug output to the console. This application is configured via a XML file that we'll discuss in the next slide, and one feature is that it supports multiple feeds. So you can select multiple assets or groups of assets that you want to send to the GeoEvent processor. It also supports multiple formats. For the demo we're using a comma-separated file format. There are some provisions to also use the JSON specification by ESRI. We haven't really used that. We haven't really tested it, but it should give you some reference if you wanna use that format. There's also the possibility of not just sending it to the GeoEvent processor, but basically dumping the output to a file, and this can really help you debugging when you're connecting to the GeoEvent processor. We also have logging capabilities via nlog. This will allow for a very customizable logging experience. Right now the default is logging to the console and logging to a file if you're running it as a service. And if you're planning on running this, please run it close to or on the Pi system for low latency when retrieving the assets and retrieving the current values from the Pi system. So a little bit about the how to configure this application. There's an XML file that's included in the project, and it allows you to specify one or multiple feeds. And a feed is basically a collection of assets that you want to send to the geo event processor. So you can configure an interval. This is basically the interval at which the application will pull for assets and for new current values. You can select a name that's used when dumping two files, and you can have a bad value substitute. So if there's no good value coming out of the PI system, you can substitute it by something else. It also allows you for some custom authentication if the application is not running on your local domain. So you can supply a authentication using a username, password, and a domain. The next step would be to configure the attributes you're interested in. So if you look at the above feed, we're configuring wells. So in this case, we're interested in attributes that are related to that well. So in this case, for instance, bottom hole pressure, the bottom hole temperature, flow rate, flow tubing pressure, and hydrostatic head. Those are the attributes we're interested in and which we want to get the current values out of. And there are a couple of ways to select the elements you're looking for. In the above example, we're using an element template named well. So in this case, it will take all the elements that are instantiation of the well element template, and it will send those to the geo event processor. In terms of destinations, you can select multiple destinations. In this case, we've configured a file destination, which will dump the output in CSV format to files on the disk. And we also configured a URL destination, which uses HTTP post to send the comma-separated files to the geo event processor. And as you can see in this example, we've configured two feeds, one for wells and one for maintenance vehicles. There's not a limit to how many feeds you can have, so it really depends on your use case and what layers you want to show on the map. So looking at the implementation of that, if you look at the configuration file, that really reflects how the project is set up. So we can distinguish on different targets. So we can have an AF element target, which allows for you to just set a path to a specific AF element. And you can use multiple of those in your feed. You can also set the AF element template target, which we used in the configuration example in the previous slide. This will allow you to basically select a AF element template and use all the instances of that of elements that implement that AF element template. You can also configure multiple destinations. So in the sample, we already saw the file destination and the URL destination. There's also research being done on using the feature service REST specification or the JSON specification. There's a sample for that included as well. We haven't thoroughly tested that, but you should be able to use that for your research. Also, you can supply multiple formatters. So like mentioned earlier in the demo, we're using a comma-separated file format. We also made provisions for using the feature object JSON specification, which you should also be able to use. Then we have the feed class, which basically ties the destinations, formatters, and targets together. And that's really a representation of the feed configuration that you can have in your configuration file. So what it basically does, it uses AF SDK using the specified targets to retrieve data from the PI system and formats it using the configured formatter. So for instance, CSV or the feature JSON format, and it sends the data through the configured destinations that you have configured in your XML file. So this is really where it all comes together. So I hope this gave a quick overview of the server-side code. If you have any questions or any detailed questions regarding this, please feel free to post it on our users community with the link provided earlier in the video, or use it on OSIsoft Virtual Campus, and we will be there to help you and assist you in your researching efforts. Thank you very much. In the next video, we'll discuss the client-side code. So that's the JavaScript and HTML client. And we'll also discuss the MVC for implementation and the REST client implementation. Thank you very much.